Our lesson today is 8.6, quadratic equations, perfect square trinomials. So our essential question says, how do you identify a perfect square trinomial? Well, a perfect square trinomial, what that looks like is, it's a perfect square. So the binomial factors are exactly the same. They're exactly the same. So a perfect square trinomial, if I start with a plus b squared. Remember, that's the same as, I'm going to write up here for a minute, a plus b times another a plus b. So if we factor a trinomial and we get the exact same binomial repeated twice, that's a perfect square trinomial. So I'm going to try and kind of work backwards here to show you what this factoring pattern looks like. A times A would be A squared. My outside product would be A times B, or AB. So would my inside product. B times A is also the same as AB. And my last product, B times B, is B squared. So, if I successfully FOILed these, I would get A squared plus, I've got two of these ABs, because I could put a 1 in front of them, and then plus b squared. So this is a perfect square trinomial, So right here, this is a perfect square trinomial because if I factored it, I get the same factor repeated twice. A plus b times a plus b, or a plus b squared. So if both of your factors are exactly the same when you're factoring a trinomial, that makes it a perfect square, because it's a binomial times itself. If I had, instead of a plus b, if I had FOILed a minus b, what you would see is I would get a squared minus 2ab plus b squared. And that would also be a perfect square trinomial. So as a factoring pattern, what you see is that you've got the a squared and the b squared in both of these trinomials, but it's that middle term that says either plus 2 times a times b or minus 2 times a times b. So it's just a factoring pattern. I don't really recommend memorizing it. I don't really recommend that. I would prefer that when we factor something, if your binomials are the same, then you would recognize that that is a perfect square trinomial then. Okay, so factor, is it a perfect square trinomial? X squared plus 6x plus 9. So x squared, we know, means x times x. So I start both binomials with x. Then I move all the way down to my last term. 9 could be 3 times 3 or 9 times 1. To get a middle term of 6, I'm going to guess first that it's 3 plus 3. So if I FOIL this, I get x squared plus 3x plus another 3x plus 9. So my middle term checks out, and I've FOILed this correctly. So because I see both of my binomials are x plus 3's, I'm going to say, yes, it's a perfect square trinomial, and it is x plus 3 squared. So this is my final answer. The next one, if I factor x squared, x times x, and then 16 could be 4 times 4, 1 times 16, or 2 times 8. And I recognize that because it's a positive when I multiply, but when I add, I get a negative. These actually all need to be negatives. So to get negative 10, I'm pretty sure 4 and 4 are not going to work. I'm going to try negative 2 and negative 8. So x squared minus 8x minus 2x plus 16 is what I get when I FOIL this. And then if I combine these two together, I get negative 10x for my middle term. So this is my answer. And no, that is not a perfect square trinomial because my two binomial factors are different. I have x minus 2 and then an x minus 8. Okay, next. 25x squared, that could be 25x times x, or 5x times 5x. I'm going to try the 5x's because remember we're looking for perfect squares, and perfect squares would have to look the same. If I move down here to 1, 1 is just 1 times 1. A negative on my middle term means they both have to be negatives. So let's see if this is a perfect square. 25x squared minus 5x minus another 5x plus 1. Putting these two together gives me negative 10x. So yes, this is a perfect square trinomial. It's 5x minus 1 squared. My next one, 12x squared. Well, I can already tell you that this one is no, because 12x squared, that's not a perfect square. So my factors either have to be 4x times 3x, 6x times 2x, or 12x times x. I don't know which one's going to work. I know if I move over here to 25, though, it has to be 5 times 5, or 25 times 1. So I'm going to try the 5's here, and then to get 5 in the middle, don't think that's going to work. If I do 4x and 3x, this would be 15 and 12, so that's 27, so that can't work. If I do 6x and 2x, this is 10 and 30x, so that's not going to work. And if I do 12x and x, this is 5x, but that's 60x, so that doesn't work. So that means I'm going to have to try 25 and 1. I don't think that's going to work either. So if I try all of my combinations with 25 and 1, 75 and 4x. If I reverse those, that wouldn't matter. So if I put 3x and 4x, this is 100x and 3x, so that won't work. Six x and 2x, 50 and 6, that doesn't work. If I switch these around, nope, 2x and then 25 times 6x, that's 150x, that won't work. So none of these are going to work on this problem. So if you cannot factor it, it is prime. Okay, now we've got some solving to do. So remember that in order to solve this quadratic, we are going to have to make sure it's all on the same side first. So I'm going to add the 64 and set it equal to 0 so that we can set it up for the zero product property. Now let's check and see if this one's a perfect square. So 9x squared would be 9x times x, or 3x times 3x. So I'm trying the 3x's first. And then 64 could be a lot of things, but as a perfect square, it would be 8. So I'm going to try and see if it's 8. They would both be negatives. So negative 24x and another negative 24x. Perfect. Negative 48x. So we factored it correctly. Now, when I do the zero product property, I only have to solve one of these binomials because they're exactly the same. So I would add 8 on both sides and then divide by 3. So x equals 8/3 is my only solution because both of the binomials would give me the same solution. Okay, my next problem. Now this problem, this can't be a perfect square trinomial because it doesn't have 3 terms. It's not a trinomial at all, it's a binomial. So I noticed that if I factor out a 2, dividing them each by 2 would give me y squared minus 16. Now this problem looks familiar to me. It's actually a difference of squares. So what you'll see in this section is you'll see some review happening. So you might not see all perfect square trinomials, you might see some review problems. So this is actually a difference of squares. Y times y is y squared, and negative 16 is positive 4 times negative 4. So if I solve for these zeros, I will get negative 4 and positive 4 for my 2 solutions. Remember, if you need to set the binomials equal to 0 and solve, go ahead. So set each one equal to 0 like this and solve them. And that's how I got my negative 4 and how I got my positive 4. Okay, this next problem, I'm going to move the 50 over. So it would be 8x squared minus 50 equals 0. And now I can take out their greatest common factor. I can divide by 2 because then I get 4x squared minus 25. And now it's a difference of squares again. So after taking out the greatest common factor, now I can see that 4x squared would be 2x times 2x, and negative 25 is positive 5 times negative 5. So to solve each of these, 2x plus 5 equals 0. I would subtract 5. 2x equals negative 5, and then divided by 2. So x equals negative 5 halves is one of my solutions. And then the other one, I set the other factor equal to 0 for the zero product property. On this one I would need to add 5 and then divide by 2. So this one just gives me a positive 5 halves, where the first one gave me a negative 5 halves. Remember, if there's a coefficient in front of your variable, I think that you should really write out your binomials and do your zero product property and show your steps to make sure that you're not trying to rush through things. Okay, our last example, I need to do some rewriting to get these all on the same side. So I'm going to move both of these over, which will change them into positives. And to factor this one's clearly not going to be a perfect square or difference of squares or anything like that, because 3x squared would mean 3x times x for my binomials. And then 2 would have to be 2 times 1 or 1 times 2. So I'll try 2 and 1 first. And then I'll check. My inside product is 2x. My outside is 3x. Add those together. And I do get my middle term, 5x. So now I can solve each one of these. Set them equal to 0. 3x plus 2 equals 0. So subtract 2. And 3x equals negative 2. Divide by 3. And x equals negative 2/3 for for my first one. My second one is a lot quicker than that. Set it equal to 0, and I just have to subtract 1. So x equals negative 1 for my second one. So factoring, there are lots of different kinds of factoring problems that we've seen throughout Chapter 8. Individually, they may seem pretty easy, but when they're all mixed together, there's a lot to think about. So please make sure that you are practicing all of the different types of factoring problems and kind of practicing them, not just one at a time, but kind of mixed together as a mixed review to make sure that you've got it all figured out. Okay, 2 more left to do. X squared would be x times x. 36 could be 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. The one that's going to give us a 12 in the middle is 6 times 6. If you FOIL it, x squared plus 6x and another 6x, and then 6 times 6 is 36. So you can see that that middle term works. The zero product property, because these are both the same, you only have to solve one of them. So subtract 6 and you're done. X equals negative 6 is your only solution. Last one. I noticed right away on this problem that I can actually take out a common factor first because they've all got an x in this problem. So I can factor out an x first before we try factoring the rest of this problem. And then 2x squared is 2x times x. That's the only way you can get 2x squared. 15 could be, we have a negative in the middle, so it could be negative 1 times negative 15, negative 3 times negative 5, or you can reverse these, because remember one of them is being multiplied by that 2x, and the other one is not. It's just being multiplied by x. So here and here, one's getting multiplied by 2x and one by x. So to get an 11, I think I'm going to want this one. So minus 5 and then minus 3. So my inside product is negative 5x. My outside is negative 6x. So they would add to negative 11x. Perfect. Then I can solve for my zeros. This one is just going to be a positive 3. And then this one, if I set it equal to 0, if you've got the hang of this, it's going to be a positive 5, but then divided by 2. So 5 halves. You should be able to write a summary now, and your homework is a worksheet today.